Alrighty, this is Algebra 1, and we're starting with lesson 97, and we're talking about the Pythagorean theorem, okay? Really important concept in both algebra and geometry, so make sure you learn it. You'll need it in geometry next year as well. So let's just have a little triangle reminder real quickly. Remember that there are 180 degrees in each triangle. You all were pretty good with that when we went over that earlier this year. For the Pythagorean theorem, we must have a right triangle, which means that there is that 90-degree angle in one of the angles of that triangle. So that's an important precursor before being able to use the Pythagorean theorem. Okay, so the Pythagorean theorem is a long word to spell, and I have to keep writing it out, so sorry if I misspelled something at some point. Okay, it requires that right triangle. So you're going to see these pictures, and they're going to have some variables around the triangle, probably maybe some numbers for sizes of sides. And then here is the actual theorem right here, kids. So it's a squared plus b squared equals c squared. And your book actually has a nice drawing. So when you take notes and that, you might want to draw that out. It really shows what this is talking about. But largely, we have the two sides of the triangle right here, A and B. And it doesn't matter which one comes first really in real life, but they, typically A alphabetically comes first, so they put it there in the formula. C has to be the hypotenuse, okay? So that is the side across from your right angle, all right? So when we're doing this, we're going to take the square of this number plus the square of this number, and we're going to add those up. And that's going to equal the square of the hypotenuse, the C. Okay, and so those are the problems we're going to try to kind of tackle. Okay, so I'm going to adjust my little folder there. All right, so practice A gives us this. It has a right triangle. Oh, I should have written that was a right triangle. I'll add that in right there. Okay. And it says one of the sides is 5, one of the sides is 6, and one of the sides is P. Now, P, we're going to represent that as C, or we're going to substitute that in for C, okay, because that's the hypotenuse. So I write my Pythagorean theorem out, a squared plus b squared equals c squared. That's a C, not a 0. Okay, then I'm going to plug in my values, right? So like I said, it doesn't really matter if the side of 5 gets the A or the side of 6 gets the A. It doesn't matter. You just have to have one of the sides equal 1. The other side equal to the other. So a squared, 5 squared, plus 6 squared equals p squared. Okay. Then I simplify. So I have 25 plus 36 equals p squared. I just squared both. Okay. Then I'm going to add that left side. 61 equals p squared. Now in blue there, you can see that I took the square root of both sides, and I did that so that I could get p by itself. I wanted to find out what is p. I don't care about p squared. I want to know what p is. So I took the square root of p and the square root of 61, and p is just the square root of 61, radical 61. Okay, and that's how I leave it. All right, let's do another. Okay, so this is B, and they wrote this triangle upside down. And we notice that the right part is here, and 15 is the hypotenuse. So we have to be careful how we're plugging things in. So we want to plug it in correctly. So there's my formula, a squared plus b squared equals c squared. Okay. I'm going to substitute f in for a. So f squared plus 5 squared equals 15 squared. Okay, and again, it doesn't matter the f and the 5. We could have had 5 squared plus f squared equals 15 squared. That's okay. So f squared equals 25, or plus 25 equals 225. We're going to subtract both sides by 25 to get f squared by itself. F squared is equal to 200, okay? Then we're going to need to take the square root of both sides to get f by itself. So f is equal to square root of 200. We recognize that's not in simplified radical form. So we could have done the prime factor tree, or you may have noticed that square root of 100 times the square root of 2 equals the square root of 200. And the square root of 100 is just 10. So my simplification is 10 radical 2. So that is our first lesson. I'll be right back.